Hey, welcome to some more math with Miss Wimmer. Today's learning target, to simplify fractions. And I know right away you're going to say, ugh, I got this. I don't need to watch this video. But stay tuned because, of course, there's going to be some variables in here and we need to know what to do. Before that, just a little review. The first thing is equivalent fractions. Ignore this, I can't get it to go away. Some part of a picture stayed on there. So, equivalent fractions describes the same part of a whole. So, if we said, instead of a blue bar right here and an orange bar, you know how Twix come in 2-packs? If you took the 2-pack and shared one with your brother or sister or neighbor or cousin or someone who you feel like sharing with, and you say, oh, I ate 3/4 of my Twix bar, and your neighbor, cousin, brother, sister says, I ate 9/12 of my Twix bar. Turns out you both ate the same amount. So you might want to argue, no, I ate 3/4. No, I ate 9/12. No, I ate 3/4. No, I ate 9/12. You both ate the same amount of your Twix bar. It shows us over here why it's the same, because you've multiplied the top and the bottom by the same number, 3. It could also be 2. So if you said you ate 6/8 of your Twix bar, that would also be true. If you said you ate 15/20 of your Twix bar, that would also be true. So how many possibilities are there for equivalent fractions? Did you say infinite? Because infinite is right. There are so many possibilities that describe the same part of the whole. So go ahead on your notes and find 2 equivalent fractions to each one listed on your paper. Pause and go. So I just happened to pick 2 and 4, multiply the top and the bottom by the same number. I get 10/30 and 20/60. The nice thing about equivalent fractions, you don't have to have either of those. You can have 2 totally different fractions and also be correct. What about 10/12? I like to pick 2, my brain just likes to. Again, I have 2 examples, you didn't have to have the same examples. And I was wondering if anyone, instead of multiplying, divided. Did you? I'm glad you thought of that. That is a special type of equivalent fraction called simplest form. simplest form is a fraction whose numerator and denominator have no common factors other than 1. So when we were doing GCF yesterday, sometimes their common factor was 1, and that was okay. That means that it would be in simplest form. If you can divide by something other than 1, that means you're not in simplest form. So for simplest form, we're only going to divide. For equivalent fractions, we could multiply or divide. Still equivalent. By the way, base word of equivalent, equal. For simplest form, we're only going to divide. Also, you might need some of those factors or divisibility rules, because 15/57ths, a lot of people think, I think that is in simplest form. But if you add 5 plus 7, you get 12 divided by 3. So guess what that means? I can also divide 57 by 3. Now I don't know 57 divided by 3, so I'm going to need a side problem. Turns out it's 19. Now this isn't always true, but I do notice that 5 and 19 are both prime. So the only number they have in common is 1, and dividing by 1 gives me the same number. So I don't need to divide by 1. I do know that's my simplest form. That's one way to know if they're both prime. However, 4/7 is also simplest form, but 4 is not prime. But the only factor they have in common is 1, so that means I have simplest form. Go ahead and the first boxes on your notes ask you for simplest form. Pause and go. So 6 and 8 have a 2 in common. So that's going to be 3/4. 3 and 4 only have a 1 in common. 9 and 12 have a 3 in common, so that's going to be 3/4 2 times in a row? That makes me suspicious. Does it make you suspicious? Do you think this one's going to be 3? I know, I'll just write 3/4 because the first two were 3/4, so the last one's definitely 3/4. Besides, what can I divide 35 by anyway? You're supposed to be whispering 7. 7. Good thing I didn't write 3/4 because it was actually 4/5. So you might have been thinking, what is this fraction lesson doing here in the exponents chapter? Which is a good question, and I'm here to show you why. I'm just writing this a little bigger so I have room to write. Similar to the numerical fractions, I'm looking for what I can divide by, what they have in common. 6 and 8 have a 2 in common. 9 and 12 have a 3 in common. 28 and 35 have a 7 in common. What do y and xy have in common? Are you saying y? Because they definitely have a y in common. What's y divided by y? 1. What's y divided by y? 1. But we have an extra x over here. It stays. X divided by y? Nope. It stays. Also, you might remember that a 1 in front of a variable, you don't have to write. Can you? Totally you can. But you don't have to. Okay, back to those exponents. Remember we practiced expanding them out to b's. And then actually, you want 2 parts, a numerical fraction and an algebraic fraction, separately. You want to do them separately. Now, 3/12, you probably could simplify before you even got here today. We reviewed it, but you've been doing this for a while, so we know that's going to be 1/4. But that's only half of our problem. What do ABB and AC have in common? A. What's A divided by A? 1BB. What's AC divided by A? 1C. If you remember, a 1 in front of a variable you do not have to write. This is not a math word. Lastly, I should have put this down here. Lastly, we are going to, not a math word, smush all of that back together. How do you write BB again? Oh, B squared. Again, you can write the 1 in front of a variable, but you don't have to. It's okay to think, whoa, I haven't done this before, because you haven't done this before. What do B and ABC have in common? Did you say B? Good, because they have that in common. On the top, what's B divided by B? 1. On the bottom, B divided by B, 1AC. You can't do A divided by B. You can't do C divided by B. Just B divided by B. Again, you don't have to put a 1 in front of the variable if you don't want to. But you do have to leave the 1 on the top. You can't have a fraction with no number on the top. So the 1 does have to stay on the top. How do I know? There's no variable here next to it. So I'm going to leave it there. When you have numbers and variables, you should split it into 2 parts. Numerical, algebraic. What do 2 and 6 have in common? 2. 2 divided by 2, 1. 6 divided by 2, 3. What do MN and M have in common? M. What's M divided by M? 1N. What's M divided by M? 1. You don't need the 1 in front of the n. And actually, you don't need a 1 under a fraction either. That's just telling you that n is a whole number. But it also signals that n should be on the top. Without it, some people kind of forget, where should n go? Top, bottom, float around, where should it go? So now, here's my not math word again. I'm going to smush this together. 1n over 3. Do you need a 1 there? No. Could you have it there? Yes. Okay, numbers separate. Oh, x to the second. X, x, y. (24) and 8. What do they have in common? 8. X, x, y, and xy. What do they have in common? xy. What's xy divided by xy? 1. What's xy divided by xy? Just x is left. Now you don't need a 1 on the bottom. But if it was there and you smushed it back together, that's the not math word of the day. What's this telling me? A 1 on the bottom tells me that 3x is a whole number. So I've simplified all of this down to 3x. Go ahead and try these last two. You're going to have to pause and separate the numbers and the variables and stretch out some variables. Go. I always hear people say, well, I'm not good at math, I can't do this. Every single person can separate the numbers from the variables. Also, you've been simplifying numbers in fractions for a very long time. So start with that. Then look to see what variable is in common in the top and the bottom. I have an AA and an AB. What's in common? A. A divided by A is 1, but there's an A left at the top. AB divided by A, a B left on the bottom. Don't need that 1 in there. Smush it back together. Be careful on this bottom part. I'm noticing on my own writing, the 6 and the B look very similar to each other. So I'm going to be a little bit more cautious on my answer to try and make the 6 and the B look different. Hopping over here to the right, What do x, x, y, and x, y, y have in common? 1x, 1y. 1x, 1y. Looks like I have 1x left on the top. I have 1y left on the bottom. No ones hiding on this problem. So I'm going to smush this back together. And I'm done. This is brand new to you as a 7th grader. So don't panic if you don't know the very first one. A little bit of practice and we will get better and better.